All right. The live stream should be started. Let's just give this a test, then we'll tweet it out. This is always the fun part. Check the audio. All right, audio seems to be good. We are ready to tweet it out. It's on my own. Printer. Okay. All right. We have the Twitters. I'm gonna get the chat popped out so I can have that in a separate window and monitor it. OBS as well. Casey, you're kind of seeing an infinite loop here, but just real quick, this is the setup I have. That's kind of fun. Just 1/3 chat, 2/3 OBS, just so I can see what I'm doing and how the live stream looks like. In the meantime, let's get going. Hi, everyone. Welcome to the live stream. If you've been tuning in for the other videos, I'm rebuilding a 3D printer from years ago with parts I started last year, and using this live stream as motivation to finish up the project. I haven't turned it on probably in over a year and a half. I have a sort of crappy mini 3D printer that I use on the side, but all these parts were printed with this working, so this did work at one point. In summary, I had a Duplicator I3, a popular low-cost 3D printer at the time when I bought it, I don't know, X years ago. And this design takes some of the innovation that's been happening in the space with Prusa, fantastic 3D printers, which I've also built before, and reuse as much of the electronics as possible. So we're at the last phase of this open source guide. I am on section 9. This is basically cabling, wiring. This will be truly the first time in over a year that I've turned on any of these electronics and see how this will function. We already know that I have to reprint a collection of parts because I didn't do them right. I cracked some of them in the process of assembly. There's been improvements by the original creator since I printed some of these parts, and so I'll be able to take advantage of those. But for now, the goal is to just turn this on and see if I even can get the wiring correct. And so in the meantime, we'll flip over to the overhead camera as we look at the instructions. Cool. Didn't do a good job cleaning my space since our last live stream yesterday. Apologize for that. So really this is all about cabling and connecting. There's some modifications, but honestly not a whole lot is left. The y-axis end stop is screwed in there. I will be getting an auto leveling sensor. Probably, what are they called? The ones with a little plunger. BT Touch. But right now I'm assuming that we don't have one. Let's see. Connect the motors. End stop cable. Run these connect the motors and the in-stop cables. Run these through the extrusion when you can. Well, that's not quite possible in this configuration, but I could probably get some more stuff in here. But we're not quite there yet. Where possible, use the cable guides to hide stuff. So I printed a bunch of these cable guides actually in PLA black, because I had some. These are PLA. And they're kind of like T-nuts, and they're supposed to just kind of drop in here, or not. Are these too wide? Well, there's different styles. Interesting. Remember, I haven't looked at these parts in quite some time. You can barely see the difference, different width, different height, right? So these are the what I'm thinking of. Oh, that's not going to fit nicely. But in any case, we will look at these later. I'm not going to spend too much time on that because I'll probably have to take this apart again. But it's meant to sort of cleanly manage cables in the channels. Oh, I see. Just as a point of reference, some of these are simple press fit. That one's melted. Yeah, like, I don't know how this is supposed to fit in. Right in the channel. I don't care. We're moving on. Modify the cable chain. This is where I was reading this morning. Modify the cable chain so that it will work with our new printer dimensions. The vertical chain should contain 22 links plus 2 end links, and the horizontal chain should contain 25 links plus 2 end links. The last 2 links in the chain should be reversed so to reduce the cable strain. I have no idea what you mean there, bud. The x-axis end stop is now mounted underneath the x-idler part with the original design. There's been an upgraded x-idler part, which we'll print soon. The end stop should be disconnected and the wire pulled out of the cable. Okay, let's take a look at the cable chain. Now, I did do a modification on my original one. How? As you can see, it just created more rigidity. Not much in functional difference, but I'm assuming this is the vertical and this is the horizontal, right? Let's just switch over cameras. Right, this is where it goes up to the gantry, and then this is where it moves back and forth. Let me move the camera and give us that better angle from the other day. It shouldn't be too much. That's really close. Yeah, that seems about right. I'm going to try to make sure that I can actually stand here too. There we go. Excellent. So what I was saying is, I believe this is the vertical chain. How about I make this a little bit higher? And then do what I did. Like so, and more of a downward looking setup. How's that? Hopefully it'll reach over my arms. Yeah, cool. I believe we want this to be like so. And or is it more like this? Probably the other way around. I'm not sure where this goes. Let's keep on reading. Top of the vertical chain should be screwed into the X gantry bottom. with two M3 screws. That's the component looks like this. Again, I think this hasn't changed much in the updated design, but you can see there's some sort of interfacing that happens. That's going to need some cleanup. Let's just pretend it fit nicely, shall we? But I think this goes into the... Where the heck does this go? We'll keep on reading. The extension box with 2 M3 screws. This part requires heat inserts. I'll take constant movement over time. Aha, we'll do some heat inserts here. It's nice and thick base. Good design. The X gantry cable box bottom. Same part. Is then screwed into the side of the X gantry idler and horizontal cable chain using 2 8M3 screws. All right, I'm going to lower this. I think what I... Curious. Some design features that don't seem to be used. There's thread inserts here. Not there, I don't think it's being used. So we'll figure that out. But you can't see what I'm referring to. Let's do this at 45 degrees. That way we can use the front-facing camera. I put 2 heat inserts here. I'll put some more. Because there is a hole here. Is that the design? I am just completely confused. But we'll learn more soon. Sorry if this angle is throwing you off. It's kind of throwing me off. The X gantry part slides directly on the bottom and keeps the cables neat. Top of the horizontal chain is then screwed into 2 heat sinks on the back of the extruder carriage. Ooh, right here. Using 2 8mm M3 screws. With the glove, you can make out the reversing of the chain. The finalized cabling shows looks something like this. Congratulations, finish should not be complete. Okay, that shouldn't be too hard. Let's get back to our cabling first. First, we're going to modify this chain. How many links do we currently have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. What? That's 24, and this says 2, 4, 2, 4, 6, 8, 10, 12, 14, 16, 24. So you're both interesting. This is missing an end link. Where did I put that end link? Or did I throw it away? That would be unfortunate. Let's see. Remember, I have that box with most of the parts I've been saving over the evolution of my 3D printers. I could have accidentally thrown away when I was disassembling the Wanhao, which would be a major bummer. Technically, it would be fine without it. It's also very 3D printable, so I'm not too worried. It just means today we'll either have to deal with the lack of it or stop to 3D print a piece. Don't see it kept cursory. One more place. Nah. Either I lost it or I threw it out. No worries. We will figure out the lack of that piece. Also, I want to figure out why when you reverse this stuff. Let's screw this. Oh, one other thing. I was complaining the other day that I don't have any other Allen keys, but I have this set and a few other sets like this that I forgot include pretty nice precision hexagonal bits. Actually, you can see that this one has very nice, even down to 0.7, size 0.7. So, for this particular component, we can get, yeah, it's 1.5, so I figured. Not rounded, but nicely machined, and yeah, easy peasy. Move this off to the side for now. Okay. Nope, I'll use it one more time. Get the right size. Where am I? These are the most adorable wrenches got from my dad. They are for timing, like automotive pinups, and they're not that easy to come by, but they're the perfect size for something like this. If I can't find the right size, then I will move to, oh, there we go. It's a Craftsman set, which is why, you know, it's higher quality than just the random set you might buy online. But they did find a few other companies who make it. It's pretty hard to find something like this since no one really, it's not needed for more modern cars. Just trying to clear out unnecessary components, which is I'm sure what happened with the other piece. I see a lot of little plastic upgrades. This has been a tried and true and time-honored tradition of 3D printer enthusiasts that you get a 3D printer, you immediately start doing upgrades. A lot of them are 3D printed, like this better bracket, some increased rigidity. I mean, that's the entire point of this whole project is to combine 3D printed parts that have been better designed into a new system. And it's nice, especially for small tweaks, like stronger mounts or whatnot. And what ends up happening is that you get to a certain level of improvement. You know, you can only make a certain thing so much more precise or faster or whatever your goal is. And then the next hotness comes out, it becomes a new baseline for the low-cost 3D printing or whatever. And then more designs get adapted. You know, innovation from previous types of printers get carried over, and you know, then improvements happen from there, and it's the evolution of this space, which is a whole lot of fun. Now, there is a ton of knowledge and free open source designs and things you can leverage, which is great if you have a very common printer. And as printers come out of favor, like this Wanhao, for example, the innovation stops. So I'm kind of getting a couple more miles out of this printer from the work of this particular project, which is really nice. I wouldn't recommend people starting with this particular printer just because there is things like the Ender 3, which is the new hotness, and there's all sorts of improvements and aftermarket products and designs that help there. But there'll be a time when the Ender 3 is no longer the new hotness. There's certainly already other printers that kind of fit the same cost profile and capability characteristics. And just be aware. And that's a good thing. I probably should have bought an Ender 3 or Creality CR10 and used that as the starting point, but I wanted to challenge myself. And I really enjoy this upgrade. I just wish I would have finished it earlier. Yeah, I have some more sanding to do. I'm getting distracted pretty easily. Let me get back to the cable chain. All right, we said this has 24. I'm going to quickly disconnect the switch while we flop this around. Not a big deal. Hopefully I won't lose it. Just double check. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, and we need 22. So if you haven't used cable chains before, super easy, right? They're made of semi-flexible plastic, and you can just kind of wiggle them open. And that's really one of the values of this design, is that you can grow and shrink your cable as you need. So I'm gonna. There are certain positions where it's easier to open than others. There's just a little bit of gentle force, maybe some coaxing with a screwdriver, and not too much coaxing. These things tend to crack. How the heck am I going to get this off? Not that end. I mean, in theory, I can get it off here, right? Yeah, in theory, what I can do is slide this forward. Shoot. No, I can't. Well, interesting. Modify the cable chain so that it will work with our new printer dimensions. The vertical chain should contain 22 links plus 2 links. The horizontal chain should contain 25 links. But you may have noticed that they're facing different ways. Interesting. Okay. We'll figure that out. Right now I've hacked together. This is a terrible setup. But we have the part cooling fan, the hot end fan, the thermistor, I'm going to guess, the limit switch, and the X motor, sorry, the extruder motor. They come out of this end, right? Cool. Ah, a better idea. Take it off the other end. Nope, same problem. Well, let's work with what we got. And get this down to 22. Because basically what I have to do is take this entire length of cable chain off and rewire it. But I want to avoid that for now if I can. I don't think it's going to impact our ability to test this. I think it's going to impact our ability to actually function, but or function well. Okay, is that original direction? Okay, where is this supposed to connect to? I'm going to assume this is going the other way. These are reversible. Okay, whatever. The horizontal chain needs 25 links and 2 end links. The last 2 end links in this chain should be reversed to reduce the strain on the cable. I think that means there's some loop back kind of setup. these pictures are not easy to interpret in black and white. I just have a black and white laser printer. Where does this connect to? There may be something missing, or I may be missing something. If you look at this bottom shot, this is connected to this somehow. And then there's something, the vertical cable goes, the vertical cable comes from here up to here. So presumably something like this. And then something like this. I'd buy that. Where's the other Z cable? Let's feed that in, just so we don't forget it. All right. Making forward progress. It's the name of our game, right? I'm going to continue filing. There are design features in this that just don't make sense. I'm thoroughly confused. Okay, now it's stuck. I'm going to not use this for now. I think we want to I think, where's the mention underneath the inside should be disconnected. The top of this part requires. This is where they need heat inserts, I'm going to guess. Let's get our iron out. Still has a heat insert configured. Alright, that should be relatively flat. Let's grab 2 heat inserts. Let's fire up the iron. Nope, that's not right. There's one other size. Maybe? These are way too big. Thought. Ah. I believe these are the right ones. Looks about right. Let's get let's see. M6, M3 screws, 6 to 8 millimeters in length. Well, let's double check. Yeah, is the right size. I'll just get these in there. Let the plastic liner cool just a little bit. But this is I'm using PETG here, and it melts. It's similar but kind of different. It's a little gummier than PLA. I'm noticing. All right. I should be done with the iron for now. Turn off the power. And like with my previous videos, there's always a little bit of excess plastic that gets pulled in as you're pushing the heat insert inside. So gotta let that cool. And then just a simple run through with a screw should clear it out quite nicely. These are brass, so it does conduct heat pretty well, so I'm going to wait for it to cool down. Don't have any fans here. Well, fans that are working, I should say. An unfortunate mistake would be to push this through and then rotate the insert out. Ooh, that's not so straight. Just like that, a little excess comes right off. In this kind of setup, it's nice because I can force it. The question is, do I try to clean this up before moving on? Yeah, that's good. Anything worth doing is worth doing right, huh? You don't want to put too much pressure when you're cooking one of these things. There's a chance I can make it worse. Which you gotta be kidding me. I may have done the wrong one. Or were they both crooked? Oh no. Okay. That's good enough. Hope I didn't screw up the other one. Okay. So we need to affix this to the bottom of that. Like this around. I think. Okay. So this looks more like this. And we can making it too hard on myself. I believe this driver is magnetic. No, I'm going to use a shorter piece, shorter screw. This is an M3 at 12. I'll use an M3/8. Cool. If I can get it in there. Nice. Yeah. Perfect. And we'll do same thing. 3/8 millimeters in length. I was looking at the new design for the X idler, and it is significantly better in many ways. So that's the first thing I'm going to be focusing on in my upgrade. My continual upgrade. Okay, that's in. Remember what I said about pre-drilling holes? Do not follow my commitment. It's also not the right angle. I'm torquing this a fair bit. So it's pretty flimsy be completely honest. Oh boy. This should have been fed through the top. So that it don't crack, don't crack, don't crack, don't crack. Aha. Voila. So now we can do something along the lines of that. What do they want me to do? Oh, they want me to pull the switch out. I see. We'll cross that bridge when we have to. Now I just want to get this back in there. Okay. And the screw aside, the horizontal cable chains using. I see. This is why. So I should, if I had the missing piece, I'd use an M5. Actually, I'm just going to do that. I'm going to take this bottom piece and use it as, you know what, I need to remove all these pieces for this to work as I am describing. Basically, this would mount through, you know, like remove these two pieces, and then this would mount here all the way through the two pieces, which is no big deal. Where's the? Yeah, that's what that was showing. Top of the horizontal chain is then screwed into the two heaters at the back using 2.8 millimeters. As you can see, let's see if we can make it out from the overhead. The snake would look more like this, right? So I can move this out of the way. What I need to do is pull these off. Pull. I pull this whole thing off. Forgot to move my phone. It's going to be a pain, but it would be nice to get this done now. I don't need these quick release terminals for the. This was really shoddily done, if you couldn't tell. For the rated heater. Just don't want to pull this off. Let's see. Let's see how ambitious I want to be. Each one of these needs to be. Use a thinner screwdriver. This is a little thicker. Have other options, such as this one. Yeah. So I'll make a process out of this. Problem is all this markings. Okay, I'm going to the switch. All right, we're going to be brave. This is the heater. Fortunately, it'll be on the live stream, right? I need to replace this with a better connector. Which I'll eventually replace with a different heating system altogether. I really don't care about the part cooling fan differentiation. I try one, turns on, doesn't work, try the next one. It's easy to distinguish. I hate that they're using DuPont connectors, but there's a problem for a different day. This is the thermistor. The white is the thermistor. The white is the original thermistor. The red, which is the heater, is an aftermarket heater. Slightly bigger, just ever so slightly. And then this is, of course, the extruder motor. So if I start pulling these through, and then these through, switch better get out of here. How the heck did that get in there? Was this crimped on before? All right. Try to shove that. Does anybody have any ideas? Don't want to break any of these connectors. Proving to be fairly hard. I mean, it's nearly mechanically bigger than the space. I don't understand how I would be able to get this out without breaking it. This is curious. And I can cut the switch and then resolder it. Question is, where does the limit switch go? I'm confused, as usual. I feel like I'm missing something. I'm going to switch over to my computer real quick. Maybe some background GitHub. All right, let's switch over to 3. All right. Go back to the wiki. Where the heck is the X limit switch? Underneath there. How is that possible? An image in new tab. Oh, maybe those holes that I cracked? That's cool. That shouldn't be an issue. Great. These are polarized. What I'm going to do, let's go back to the front camera. I'm going to cut this. I don't know how I'm going to get the stepper motor wire. I don't want to resolder the stepper motor wire. But this limit switch I'm okay with. It's got this chunky connector anyway. So it'll just go like so. I don't know what a good angle here is, but that's not it. Okay. So I got the 2. It's supposed to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I'm going to take this off and then add on this other piece after I cut the connector for the limit switch. Okay, this is the Mr. Sneak you through. Come on. Before. Okay. And so I'm going to cut the limit switch connector. It is color coded, which is nice. Hopefully I won't cut any other wire while I'm at it. And then resolder this. Okay. Well, that was fast. Okay. I have no idea how I'm going to get the stepper motor connector through. It is a standard DuPont thing, but I've never been successful in getting those out. So they have little plastic tabs that hold the metal connector in. I'm worried that if I mess around with it without experience, I might break it. I'm going to try. Very, very gentle. And use a very tiny Phillips. One of my kits. Flathead, rather, I should say. As you can see, these go down to 0.8. That's round. 1. I use it as a little flat blade quite a bit. See, if I had a proper microscope, this would be easier. I have your generic jeweler's eye loop thing. Let's see if this helps me at all. I'm very nervous about this. I think what a lot of people do is they replace the plastic housing, which I don't have a spare plastic housing or new plastic housing to use. That's going to be a bummer. If I can't get this out by today, especially since I just cut off the limit switch wire. gonna mate the plug with its switch. Well, that's interesting. Let's reverse the printing on the wiring. It's all good. How do I get this out? You know what? There may be a process where I can just break every, or separate every single one of the cable chains and loosen it somehow. I mean, I don't see this getting any easier. It's the most important motor connector. Well, that didn't go anywhere. Unfortunately, I am no closer to getting this connected than I was before. The problem comes down to this connector. And I'm just worried that I won't be able to put that back in. I have very little experience with DuPont connectors. I've tried not breaking them before and have not been successful. Well, that was easy. Easier than I thought it was going to be. That's one wire. See if that gives me the clearance I need to squeeze this through. No, let's try the other side. Should still be easy. Rewiring a stepper motor is not for the faint of heart. All right, so now I have two of the wires removed. So I'm going to try to pull those through and push this. Still not enough clearance. Huh? Why have to be so difficult? All right. Going to do the on a roll. Might as well do the fourth one. Using just the tip of an X-Acto to pull up just enough. Okay. I'm not even gonna bother. I'm pushing it. Basically, what I'm doing is I'm pushing the wire and the metal interconnect against the hard plastic to leave a little space for me to fit the X-Acto tip underneath the plastic, and then just very gently pulling it up. All right, we're free. I don't have any replacements, so if I break this, there goes the stream. Awesome. All right. Can I speed this up at all? Maybe pulling the pulling that through. Free up some space. See, can I pull one out without having to break this whole thing down? Start with the thermistor. It'd be really nice if I don't have to take every single one out. Aha! Now, one of the fans. Come on, little fan. Connector. Aha! Now I get these off. Okay. The horizontal cable should contain 25 links and 2 end links. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So this is like so. And 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23. 24. Oh boy. It's supposed to be very flexible plastic. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And then instead of the normal orientation, the last two links should be reversed. Great. Crap. Okay, let me just double check. I keep on, math is hard for me. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23. So the last two links should be reversed. I believe that's like so. Did I get that right? Bottom one off. Something like sixteen, 18, 20, 22, 23. How the heck is that supposed to work? Ow. Okay. Like so. Why am I so confused? These two are not the same. One is an outside connector, one is an inside connector. That's cool, that's cool. I will we'll just let it be and probably 3-print a alternative component. Also, once I figure out why this is all messed up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. I mean, honestly, I don't see how this is any different in this photo. So let's start feeding things through. Huh? Shall we? Be nice not have to do this so many times. Okay. And another one. This is the thermistor. Sorry if this is boring. It'll be nice once I have this done. Come on. The real question is how do you get the loose wires through? Specifically, the hot end wire, or the motor. Let's take these two hot end wires. At least they're stiff. Crap. Okay. They are through. And for the most challenging set of wires, the servo motor wires. Kind of want to. I just want to This is proving out to be hard. Let's reverse it. Pull them out. This is the tedium of 3D printing. Push this through. And get this to the other side. I'm not going to connect the plastic housing just yet. It's unclear how easy this will be to do again if I need to. One, two. So I don't want to bundle these together with tape because that would leave some residue. So every connector, I'll just gently push it in. See which one's going to be the problem. Okay. We have that loose wire. Let's get this one through. Ugh. Now just to get the 3 DuPont cables through, and oh boy, this is going to take a while. There are other ways to snake wire through cabling, or chain cabling with a thing like this. The right way is to attach some sort of cable. They have a term for it, but basically it's a stiff wire. This is what electricians might use to get wiring through a conduit. A stiff wire that has a reel, and you can feed it in one direction. So I maybe like feed it through this end, grab the wire you're trying to reverse through, and then pull it out the other end where the cable feeding mechanism started. Don't have that or anything that I could use as an ad hoc solution there. So just feeding things through and hoping I don't screw it up in the process. I got 2 more fan connectors to deal with. Well, that's easier. Relying on the stiffness. There we go. And 1 down. 1 to go. I find if I'm stiffening the cable chain, it's been making it a little bit easier to force it through the different sections. But now that this is filling up, it's getting a little tougher. Definitely think this was assembled. The wires were fed before the connectors were added. There's no way they easily got this through. Well, let me reverse that. Try another angle of attack. Wow, this is going to be tough. Not even past the first chain link. Well, if I rock it back and forth, it actually helps quite a bit. These DuPont connectors are just big enough where they make it hard to. Oh, that's cool. was a real pain. Hope I didn't screw it up. Can't see where I'm at, but I'm at the very end. Basically, I can't feed it anymore. The stiffness of all the other wires in the bundle are preventing me from moving it forward. So I have to just kind of like inch it through. And we are almost home free. The recommendation looks like they go to the other side. So before I pull that all the way through, I'm going to reverse these. Since now is the easiest time to take care of that. So happy nothing broke so far. That poor DuPont cable. Okay. The last DuPont one to be set free. The last fan connector. Come on. I'm going to try to pull it out with tweezers. Sorry for being off camera. And whew, all are through. So I need to get, oh man, that took a while. 8mm screws. 1, 2, and there is the right driver. Okay. Okay. Try to make some semblance of organization. And so eventually this will be fitted here. Huh. I think I have some figuring out to do, but because this should go get bend in the opposite direction. Oh, I see. That I can fix in place. These two need to break off. And rotate. In place, perhaps? Or I'm going to be smart and remove this. So close. Actually, it's just enough to kind of not torque on them too hard. Never mind. Coming out. Then last one piece, actually like so. I think that's right. All right, come on. Don't be shy. They're so close. Great. So now, sweet. That's right. That was bound to happen. Ooh. Wheel? We are very close to trying this out. The last thing I want to get in there is the limit switch, which I am uncertain how to mount this correctly. And this must go upside down in the part that's cracked and that I didn't drill out beforehand. I am going to move it on its side. Make everything a little bit easier. Don't make cracking noises, please. Thank you. You can't see much. Basically, I have to put the 1.5 millimeter right there. Boy, oh boy. Not only is this a terrible idea, I have no idea if I can reach that. Great. Alright, let's try without the extension. This is very bad. I have no idea how I'm going to make this work without breaking something. Many things, actually. This won't fit. Where is the switch? Switch. How much will be poking out? Okay, I'll probably. These are very close. A lot of things are just right now. Mostly me. Okay. Let's move this over here. So there's basically no space. And I have to effectively tap this with very tiny screws. I don't like this design at all. I'm going to try and use very tiny drill bits to open this up. I don't think I have small. It's organized in any way because the box opened somewhat abruptly. It's pretty hard to keep this organized. Let's see. Too small. Way too big. No way. Well, a little perseverance, I guess. Please don't crack anymore. This part's going to be replaced because I did crack it by not pre-drilling the holding holes for the linear rods. There we go. Hey. All right. Installing the switch. Guess it doesn't really matter which way it goes. Except not on the floor. Okay, we are 95%, 98% done with the things we're going to try to accomplish today. So, with that, I'm going to turn this back right side up. Get this out of the way. I'm going to be brave and insert the connectors. Oh shoot, the orientation is, oh, yeah, okay. So printing side up, each goes this way. Well, the wire got bent. It's not feeling very happy right now. Okay. This is what I was afraid of. Maybe a single one will snap it. John, keep on going. Not going to do the plastic enclosure. I'm just going to turn this thing on. See if we get any movement whatsoever. Because right now, getting a little tired. All right. This is an important milestone. Not the most important, but let's power this up. Off. Insert the power cable. That's not good. Okay. Scared me there for a minute. Nothing should be shorted. Well, of course there's know where its temperature is. You can't see the screen because of the brightness. Does that help? Don't know how to turn off the backlight. Okay, we turn this on. So the thermistor is not installed, so we will. Well, the heated bed should be connected. Let's worry about that in a moment. This is a thermistor, and this is the screw-in thermistor I have. This is the hot end. Never mind. Okay. This is the thermistor. Shouldn't matter. Okay. Well, here's one fan. Might be the right fan. And then really connect. Try toggling it on off. The is my janky At the other end of the heating element, I really need to just cut this down in length, and I will. For now, I want to. Okay, both thermistors are being registered correctly, which is a good sign. Let's see, fan speed. Okay, turn the fan off. Let's try the other fan. Oh. Okay. Wrong fan. Smell heat. Quite literally the only thing that's on is the heating elements. Fan. Okay, let's open up the Noctua box. See, there's an adapter we should use. I was hoping for something there. Let's see between these two. Low noise adapter. This is so fancy. What am I using? Omni join. I don't know what that means, but let's plug this in. And these two. Oh, that's quiet. And what is this? Start with that. Okay. All fans are on. It is cool. I'm not gonna do any hot end adjustments. Position. All right, no. We position the Z first. Well, that's a good sign. Let's do some Y position. Well, it's moving. That's good. Definitely think the X is not. This is fast. Well, we have something. This is awesome. Don't want to install the last parts of the heater bed just yet because I have an upgrade or two to make. Where's my temperature bed? What I want to do is try to home the Y. Ooh, it's doing stuff. Okay, we're at 28 degrees on the thermal gun. I'm going to go and set the quick settings. No. Back. Okay. Extruder. Okay. You know what? I think I'm going to end it here because we've had our first successful boot up of the 3D printer. All X, Y, and Z motors are moving correctly, which is awesome. Got to reconnect the extruder motor, some more wiring, and then install the springs and an upgrade or two along the way before we start actually testing printing, which will be exciting. I already noticed that I think the X is maybe a little bit, needs some tensioning, but right now I'm really excited. This is a huge step in progress for me and this 3D printer. So thank you if you're watching the live stream. Thank you for watching it regularly on YouTube. If you have any questions about the project or suggestions, please let me know in the comments below. Anyway, thanks. Have a good one. How do I end this live?